Hey, thanks everyone for joining for today's Pangeo Showcase presentation. I'm really thrilled that we have Deepak Cherian here to present on Xarray's GroupBy. Deepak is a forward engineer at Earthmover Public Benefit. I'm sorry, I don't know if C is corporation or company, but Earthmover, who's doing great work in our open source community, and a longtime Xarray maintainer who is generally obsessed with GroupBy. So thank you so much, Deepak, for being here today, and please take it away.
Great. Thanks, Max. And thank you all for coming. As Max said, my name is Deepak Cherian. I've and I work today at Earthmover, where we're trying to revolutionize n-dimensional array data in the cloud. But today's talk is about more of some of our open source focus. And today it's specifically on the Xarray package. Um, So yeah, I have a background as a physical oceanographer, most recently at NCAR, the National Center for Atmospheric Research. While I was there, it became pretty clear that our ability to work with these large data sets was really kind of holding Earth sciences back. So I got pretty deep into the open source Pangeo community of software, mostly Xarray, but also Dask, Xarr, and most recently IceChunk, which is an open source storage engine that we're building at Earthmover. So you should go check that out if you haven't heard about it. More generally, so I've started spending a lot of time doing open source maintenance and kind of community work. And at an algorithms level, I'm pretty obsessed with GroupBy, which has kind of motivated a lot of stuff that I've been doing kind of on and off as a volunteer for the last few years. And so this talk is going to be about that. So what is GroupBy? If you don't know, it's kind of a very common analysis pattern. It's usually you take some data, you label it in some groups. This usually encompasses things like binning, right? Or histograms, composites. So you composite by an ENSO phase or something like that. That's a group. You're grouping the data and then applying an operation on it. And then in the earth sciences, you'd call it climatologies. So things like the monthly mean climatology or something like that is also a group by operation, right? And so when you abstract all of those, binning, histogramming, and all of that out, what you get is you take your data, you label it with the labels of some groups. These could be like the bins each data point belongs to. You split the data set into those groups. So you take all the data in a single bin, you apply some function, and then on all of the bins, and then you bring them back to combine to form the result. Right, so this is why it's commonly called like split, apply, combine. But the labeling piece, the like actually like dividing your stuff into bins, is also an important part of this. So I tend to think of it as label, split, apply, combine, and it's pretty general. Uh, in Xarray, we provide this API called GroupBy, so you can call dataset or data array dot GroupBy something. Something can be a categorical GroupBy, so something like time dot month. Dot mean is probably most of you are familiar with. This gives you the monthly mean climatology. So you will, sorry, yeah. And then you can do things like group by ENSO phase. So that's kind of like a compositing approach. And you can call a mean on all of those groups and construct a composite for each phase. You can do binning using the group by bins. So in this case, it says, hey, to group by bins, take the temperature variable and bin them into these bins and then take mean, right? Resampling is also technically a group by operation. So in this, you have sequential groups and you say, hey, every group in a single month, let me take that together and then calculate the mean. Schematically, this looks like this. So the categorical or binning, you can think of, hey, I've got these two chunks of data. Each color represents a different group. And so I'll use this kind of throughout the talk, where each color represents a different group. This is my input. I split the data into stuff, do my operation. In this case, I'm reducing down, say, with the mean, and I end up with four groups in the output. So there's four values, right? So you take all of this data and you crush it down. Monthly means are similar, though you'll notice that there's a pattern here. So each color represents a month. There's 12 colors, right? And so going from 1 through 12 in like a linear scale. And there's 4 years of data. So 1, 2, 3, 4. And you crush all of those down to create the result, which is the monthly mean climatology. So there's 12 values, right? So 1, 2, 12. Resampling, you tend to take a kind of data at usually a regular frequency. And so here all members of a group occur right next to each other, right? So in this case, each group has 4 points. So 4, 4, 4, 4, and so on. And then you take all of that and you crush them down to one value per group. And so you get the resampled output, right? So all of this is GroupBy, and all of this has the same underlying infrastructure, even though they all kind of look different. Like you're grouping by a categorical thing, you're grouping by you're binning, in this case by temperature, or you're resampling to a frequency. But like fundamentally, conceptually, they're all the same thing. And so as a paradigm, GroupBy is great. Once you get the hang of it, a lot of analysis tasks very naturally can be represented as a GroupBy, and so it's great. Grouping with Dask in particular was quite bad for a very long time. And it was kind of bad in a very frustrating way. It felt unpredictable to a user. And the reason behind this was that Xarray's algorithm to actually do the group by was very, very flexible, but it was also very naive in kind of the parallel sense. Because what Xarray does is it takes the input here, which I'm schematically again showing with 5 chunks. Each color represents a member of a different group. In this case, there are, I guess, 7 in total. And so what Xarray would do is they would go, hey, give me all the members of the first group, give me all the ones of the second group, and construct 7 different arrays here. So this is the split phase. And so you can see immediately that there's a lot of very confusing communication that's happening across all of this. And then it takes the array with all the red blocks and then smashes them down to one value, right? That's the reduction or the apply step. Does that for all 7 in parallel and then stitches them together. But this mess of communication in the beginning is fairly naive and it's not very friendly to parallel systems. And it's also unnecessary, right? So a few years ago, I got very obsessed with this problem and then rewrote the algorithm to do something more like this, where you take each block, you reduce on each block, and then you kind of slowly combine these together in what's called a tree reduction to get to the end. And just flipping back and forth, you can see that the graph is immediately cleaner and a lot easier to execute, right? It just looks neater, and neater means you can execute this smoothly. So it's better in parallel. It also does a bunch of other things, but at like a foundational level, it changes the algorithm. And this makes a lot of things work much, much better. And so I wired this up to Xarray's GroupBy in 2022, 23. I did a Pangeo showcase back then. There's a cool little blog post that shows you a big improved workload. That was then adapted by the folks at Coil and Dask to show how you could reduce on a 250 terabyte national water model data set, which is pretty cool. And so as of a year ago, this was the state. We had much faster group by for both NumPy arrays, and we also had a much better algorithm with Dask, and things were amazing. But when I built Flox, I actually built it to solve more general things. So it actually lets you do a lot more than Xarray lets you. These include things like grouping by multiple arrays, grouping by a Dask array, specifying the ordering of labels or seasons, and more. And so over the last year, things have been slowly moving into Xarray, and that's what this talk is going to be about. It's going to show you all the cool new stuff you can do. And really, it's going to focus on how Xarray's group by is a lot more expressive, and you can do more complex things. And hopefully, you'll be able to do even more complex things in the future, but with a very nice API. There's some performance improvement stuff, but I'm not really going to talk about that today. It's going to be all about this expressiveness and how much more you can do today than you could do yesterday. So I'm going to switch over to a notebook. Quickly share my screen. Sorry, I'm having trouble finding it now. There you go. Okay. I assume you can see this fairly clearly. So I'm just going to work with our kind of classic example tutorial data set. There's one data variable that's 3 dimensions, time, lat, and lon. And there's 3 1D coordinates, time, lat, and lon. There's 2 years of data at like 6-hour frequency, right? So that's 6 hours away from the first point. And it's kind of a regular lat long grid. So the first thing that I'll show you is, so here's a way to calculate the monthly climatology for this data set. So you do group by time.month, and you'll get an output where the time axis has been replaced by a new month axis of size 12. So each value along the month axis is the mean of all values for that month, right? So that's what Xarray lets you do. But it used to only let you do group by one variable. What if you wanted to group by 2 of them, right? All right, so my example was this. I'm going to do time.month and time.year at the same time. And so what's going to come out is a two-dimensional. And my time dimension is going to get split into two, right? There's going to be 1 month and 1 year. So I run that, and there you go. So now you have lat, lon, month, and year. So now you have the monthly average for the year of 2013, and then the monthly averages for the year of 2014. In the kind of classic standard API, right? And so all I've changed is going from setting a single string to in this case, a list of strings, right? And so it's done the group by on these two variables. And so the number of groups is really 24, like 12 months per year, and there's 2 years. And then it crushes all the values down and then gives you this two new dimensions in the output. So that itself is pretty great. But this is also a very simple group by. It's just looking for the unique values. So it looks for the unique years as 2013, 2014, and then the unique months, so 1 through 12. So it's really this categorical grouping where there's unique values. But what if you wanted to do, say, bin along one variable and then, a categorical thing about another variable? So that's where we've kind of introduced this new concept called a grouper object, which kind of represents a group by instruction. I'll talk about it conceptually soon, but for right now, just kind of follow along, see what I'm doing. And so what I'm first going to do is I'm going to assign a new categorical variable. So that's just month. So this labels each point along the time axis with the appropriate month. You can see, it's a 6 hourly data set. So you can see, month 1 is repeated a bunch of times. And then at the end, month 12 is. This will help us because so now what I'm going to do is calculate, I'm going to combine categorical grouping and binning, right? And so what I'm going to do is say along the month, I'm going to apply the unique grouper. So this is kind of exactly equivalent to time.months with the string as you saw earlier. And then on latitude, I'm going to apply some binning. And I'm going to say bins. I can actually say just give me 10 bins. And I'm going to say, hey, give me the mean. So now you'll see the time axis has disappeared. It's been replaced by month because I've crushed it along that axis. And then I have also binned in latitude. So I've gone from, I think, 25 latitudes. Yeah. So you start with 25 latitudes and you end up at 10 because I gave it 10 bins and it's automatically picked the edges that you can see in this coordinate. So this is why these grouper objects are useful. They let you express the fact that you want to do different types of group by for different variables once you start doing multivariable group bys. You can do other things too. The other little grouper object is called a time resampler. So in this case, I'm going to combine bin grouping. I'll do again bins equals 10. And let's say on the time axis, which is a 6 hourly data set, I want to resample that to, let's see, I'll go to daily frequency. So this is kind of like the resampling syntax. And so you'll see that I've gone from 0 to the 2nd of January, the 3rd of January, and so on. So I've gone to a daily frequency, right? And I've binned in latitude at the same time. And so that's pretty cool. So this works for basically all of the GroupBy API, which means that, oops, I can do things like, here's a little GroupBy instruction. Sorry, kind of, there we go. And then I can do classic iteration type stuff on it. Let's see, let's break. And I'm just going to get the next one, right? So here's a little group that has stacked the lat and lon objects, and it's got, 1 month of data here. Sorry, 1 day of data, right? So this is all 1 day, and it will have a single bin of data along the latitude axis that comes through. So you can do all of the complex group by stuff with these multiple variable groupers, though in generally, it's great when you have this flox package installed. So here's another example. It's going to map the mean. Map is a very general function. You can give it any function that takes and does something with an Xarray object. And so this is applying x dot mean on every group X in this kind of multi-dimensional group by. Okay, so hopefully that was clear, but this is like a really major step forward and lets you express more complicated grouping operations that you couldn't do before that easily, at least. Okay, and so conceptually, what is a grouper? And so remember, like I said, I think of GroupBy as a label, then you do the split into groups, then you apply the function, and then you combine the results. And so groupers control the labeling step. And so it's what goes through a bunch of values and then puts these colors on them and says, hey, this is the orange group, that's the green group, this is the light purple group, and so on, right? And so groupers let you control this labeling step. If you've used pandas, pandas calls this factorize for categorical things, or cutting for binning. NumPy has things like digitize and search sorter, which are all kind of similar, where digitize, for example, you give it some data and you say, hey, digitize this into these bins, and we'll give you back these kind of integer codes that label each point with which bin it belongs to. And so the grouper object is really an interface to that kind of operation, but kind of a little friendlier, right? And the reason this is useful is because the only difference between a categorical group by and the bin group by bins is this labeling step. Like when you bin something, you need the bin edges as an input. When you do a categorical thing, it's really just looking for the unique values. Like that's the only difference. Once you have those labels, everything else, the split, apply, combine, all of those algorithms are all exactly the same. And so the groupers are really an extension point that lets you customize this. And as of today, I've really built the groupers that let you do things that you can do with Xarray today, like binning, resampling, and kind of unique stuff. This is pretty useful already because you can start combining them, right? You can do resampling along one, binning along the other, as I showed you. But in the future, and I'll demo this, you could do things like a custom season definition, and you could maybe write one that does resampling in space, not just time, which is also a useful operation. So here's one. Here's a super common annoyance. If you do group by time.season with Xarray, you'll get seasons, but they're out of order. They have December, January, February, and then it jumps to June, July, August, then it comes back to March, April, May, and then September, October, November, right? This is a super common, irritating problem. But the reason, the kind of in the weeds reason for this approach is because it's just looking for the unique values and they get sorted. So it's D, J, M, S. It comes out in alphabetical order, not the season order. Not very useful. And so what I'm going to do again is I'm going to apply, I'm going to save the season labels in this case as a new little coordinate object. So I've just added this little array that's got all these season names. And then this is kind of some new API that gets enabled with these groupers. You say, hey, along the season coordinate, season array, let's look for the unique values, but I'm going to tell you what the values you should find are. So DJF, MAM, DJA, SON. So this is a specified order. I've given it a list and I call mean, and it's going to come back in that order, right? And so this is, again, it's purely about labeling. And so this grouper object is an extension point. So I give you the labels that I expect you to find in the order I want you to find them, and that gets preserved. This has another benefit, which I'll show later. But for now, let's just stick to seasons. So right now I'm on this kind of dev branch that has this PR thing installed. So here's a new little season grouper. Season grouper is kind of fun because you can write your own seasons. So in this case, I'm going to just pick a little bizarre one. So I'll go do DJF, MAM, and then I'm going to just smash everything else into one JJSLD. Why not? And so you get a group by object. It applied the season grouper along the season variable, and it's picked 3 groups. And then you called out mean, and then bam, look, 3 means. This itself is kind of cool. I realized when looking through the Xarray issue tracker is for a while, the most commonly requested group by feature was just better performance with Dask. The second most requested one is how to do custom seasons. And so here you go. It gets even more fun because remember, resampling is the same as grouping fundamentally. And so here's a little season resampler object that's going to be fairly useful. Oops. And so this is season resampler, and the seasons I'm going to say are just kind of the classic DJF, MAM. Oh, here, maybe we'll make it more fun. ON. And then one useful feature this has, it's kind of on by default, but I'm just kind of making it obvious. So yeah, this will do a resampling to this kind of seasonal frequency. So you see your time axis is still time, but it's been smart. So the input time vector is useful for reference. You'll see that it starts in January and ends in December, but the first season I asked for is DJF. The first value that comes out starts in March. The reason is this drop incomplete thing. So the first season, December, January, February, is incomplete because you don't have data for the previous year's December, because the time series starts in January 2013. So you're missing December 2022. So you only have 2 months for the first season, which should have been three. And so this is smart enough to just drop it. It's also smart enough to drop the last December because, again, that's 1 month of a 3-month season DJF, because this time series ends in December. You'll see, whoops, I made a mistake there. Yeah. The last time step is in December 2014, but that's an incomplete month. So this one will end just with the October, November value for that season. So there you go. So this is why those grouper objects are now very useful. It lets you express this kind of complex logic in just like a little, and encapsulate in like a little single thing, and you can build a nice little API to it. So yeah, this is like the next most requested group by feature, is something that is smart about seasons. Okay, that's kind of quick. Do people have any quick clarification questions, or shall I keep going?
Yeah, I have something. When you showed the binning,
Mhm.
I noticed that the bin ranges were open on one end and closed on the other. Is that
Yeah.
something new with these? Is that something new? Can
Um, that's kind of the just the default, but it is configurable, which I assume is what you're asking for. Whoops. So you'll see it has things like right equals true means closed on the right and open on the left, and you can switch that. Yeah, and then yeah, there's some fairly, you can control a lot of this. There's some fairly complicated stuff that you can do to control exactly how the bins are defined.
Thanks.
Sorry.
Sure. Cool stuff. I guess my question is regarding your extension to be able to do more than one group by at a time, similar to pandas. Is there anything fundamentally different about that instead of like, as opposed to just chaining the group by like chaining them along? Is it more performant than just chaining them, or is it actually doing something that you can't do by chaining them? So I guess is the change more about just like simplicity as far as being able to do it, or is there a more fundamental change behind it?
Yeah, you can, some of these can be changed. So if you did resample dot mean dot group by, I don't know, lat dot mean or something. This is not necessarily equivalent to group by lat equals group by lat equals something, time equals something, dot mean when you have nans. Like these are not always identical, and sometimes you do care, and that's where it matters.
That's a helpful clarification. Thanks.
Good. Okay, so that was a whole bunch about these grouper stuff and grouping by multiple variables and all the things that custom groupers will enable in the future. That season grouper, season resampler stuff is still in development, and it's kind of hard, but hopefully I'll get it in soon. The next little piece is kind of generally in this kind of better group by map kind of space. And so group by, we commonly just do group by.mean or something, and that's a reduction, and it's pretty cool and fast and accelerated. But a lot of time you want to do custom stuff in your groups. This could be things like bias correction, detrending, downsampling. A lot of these climate science workflows are like construct some groups, figure out some kind of climatology by some definition through some complicated stat stuff, and then calculate the anomaly with respect to that. And so there's a lot of these like things that operate within groups and fairly complicated stuff. And so we have these true entry points dot map and dot reduce. And basically the two apply user-defined functions, which is just, you give it an arbitrary thing that will do arbitrary sets of operation and we'll apply it on every single group. So it's one of the ways we let you extend what you can do with the group by. The difference between map and reduce is that map takes functions that accept Xarray objects. That's what it will give you. Reduce takes functions that accept bare arrays. So things like a Dask array or a NumPy array. That's what you will be given with that function. And so it is fairly common for such workloads to like having the whole group in memory at once. A good example for this is quantiles. To calculate the exact quantile, you generally have to have all the data in memory at one go, and then you calculate the quantile on it, right? And so this can be hard with Dask in parallel in general. And so a couple of these ideas here are really about making these kinds of group by map analysis tasks more embarrassingly parallel or blockwise. And yeah, so yearly quantiles is an example. And so here's a link to a Pangeo thread where someone wanted to calculate just quantiles within a year of data. So it's like group by year, calculate the quantile in it. But it can be a mess depending on how that chunking is. It could be really messy. And so two little tricks that are kind of the first one is kind of, I think of it as rechunking to a frequency. This is something Dask data frame has had for a while. To make our example easier, I'm just going to resample this to a daily frequency. This is purely just to make the example easier. It's not needed. So now I have fewer points, and there's, what's that, Jan 1, Jan 2nd, so on. So it's in a daily frequency. So this is something that, again, has been enabled by adding these resampling objects. Is now you can express group by a grouped operation in some other places. So one of those is chunk. And so I'm going to say, hey, I want to rechunk the data set. And where usually you would specify, time equals 15 or something like an integer, you can give it a grouper. At this point, you can only give it a resampling thing. We can talk about that. But what I'm going to do is say this is 3 monthly frequency. So this is going to work, and then I will show you what it's done. So yeah. Oh, confused now. Sorry, 1 second. Let me check what I did earlier. Yeah. Oh, yeah, maybe this is right. I don't know. I need to think about this, but the idea here that's happened is I've said, hey, you put 3 months of data in a single chunk. And so your chunk sizes, because I have daily data, is all in kind of the range of 90 points per data set. Sorry, 90 points per chunk, because 90 is roughly like three months at daily frequency. I'm a little confused by the output, so I will check that. But the idea is this is non-uniform chunking. Sorry.
That should be February, I think.
Sorry, what do you mean?
The 90 is February's, I think.
Yeah, maybe that's okay. Maybe that's right. Yeah, so it's 31, 28, 31. Right, that's 90. All right, thanks, Eustace. And so yeah, so this is done the first 3 months of data, which is January, February, March. So 31, 28, 31, which adds up to 90. The next one's going to be April, May, June, and so on. And so this kind of this non-uniform chunk sizes you could determine on your own, but this is kind of nice. And this now lets you do things like you can map a function that expects 3 months of data in a single group and does something and so on. So that's one. You could, a more common usage of this function would be to do annual, I think AS, okay, use YS, but yeah. So that sticks 365, 365, right? But it would handle a leap year. You would get the 366 day chunk too. So that's resampling, slightly easier to think about. There is a fairly more advanced operation in data frame and data baseline called a shuffle. This is, again, in progress, but the idea behind a shuffle is that you sort your data by group label, and you sort it so that a single group is in a single chunk. This takes some thinking to get used to. I'll show you an example, but in a way, it generalizes sorting and also this rechunking with a resampler idea, right? It's like you give me these non-uniform chunk sizes, and then also on top of that, make sure that I have a single group in a single chunk. This can be useful for these group by map, group by reduce, a little more complicated operations that would be very hard to express otherwise. So here, just for fun, I've added this month variable and I've chunked the data to 15, again, just for illustration purposes. We're debating API at the moment. On this little branch, I have it as shuffled by, and you can say I said month unique grouper. So what this is going to do is it's going to sort the thing by month and then make sure the chunk sizes work nicely. And so if you look at, here is 2 years of data shuffled by month. So the first chunk, a long time, has 62 points. That's 2 Januaries, right? So 31 plus 31, because this is daily data. The second one is 2 February, so that's 28 plus 28, 56. The third one is 2 Marches, and so on. And there should be 12 chunks here. Yeah, and so what's happening under the hood is there's all kinds of fancy DAS stuff that Patrick Huffler at Coiled implemented, and Xarray is just giving you an interface to that, right? And again, the reason you may want to do this is maybe you want to calculate quantiles along the month, for example. And so now that becomes a much simpler operation, or maybe not just quantiles, you want to do other, like I said, downscaling or detrending or any arbitrary computation, and it's all going to work a lot nicer now than it used to previously once you use this API. But this is still more advanced stuff, but it's going to come soon. So yeah, you want to do this because any per group operation is blockwise or embarrassingly paddle. That's a really nice property. You kind of eat some communication in the beginning, but Dast can be pretty good at that. It composes nicely with Xarray's map blocks. If you've used that, you've probably used that if you had these kinds of workloads just to make it work. Now this will compose very nicely with that and work pretty well. And like more interestingly, you can save this kind of shuffled data set to a disk. So maybe your machine learning model wants like a batch of data that is from the same month, for example. So because the stuff has been reshuffled or sorted this way, you can just save it to disk and use it in other places. Yeah, shout out to Patrick for implementing it. We've been collaborating for a while and it's been pretty productive. We're kind of running out of time. There's other cool stuff in here. One is grouping by a chunked array. If you've used the package xhistogram, this is basically what xhistogram's superpower is, but now you can do it with Xarray too. Here are some labels. They're basically just arbitrary integers. I'm just going to group by them. I'm going to take a little chunked array. So label now is a chunked a Dask array. You can imagine this as a model for, let's say, counties in the US on a grid. And it's just huge. It could be like gigabytes, right? Depending on the resolution of the grid. And so it's not something you may want to hold in memory, but maybe you want to do a reduction on those counties. So as long as you know what those labels are, or say county numbers, you can express this group by without actually computing the group. So in this case, for example, I'm grouping by this label thing, which is a Dask array. And I tell it, hey, I know what the range of labels are because I created them. They're going to go from 0 to 19. And once you do that, and then this is kind of backwards compatibility, and they'll go in the future. But once you do that, that's all the information I need to set up a mean calculation in those groups. And it's all lazy. Yeah, so that's basically it. Previously, if you did this, so this is today's default stuff, it will load the data into memory. This one is a pretty small example, but yeah, this one's a pretty small example, so it doesn't matter. But if you do like a giant array that's sitting on the cloud or something, it would have brought it all down to my local disk, and that was not good. So yeah, I wrote this blog post a while ago that avoided this problem by using a different API, but now you could do that today with Xarray directly. A little more advanced stuff. Last thing, this is like a grab bag of stuff, but the last bit is we can now accelerate these group reductions with this nice package called numbagg. So if you have to take one thing away from this talk, is that you should run this in every environment you have, for the most part. So numbagg gives you compiled reductions with number, including for grouped reductions. Flox knows how to talk to numbagg and can be used by Xarray to enable all of this. Many thanks to Max, who's been working on that project for a while. Here, I'm going to run some timings on a resampling problem. So that's just 200 milliseconds without using any of this. So this is just the standard Xarray reduction would take you 200 milliseconds for that problem. This one is 7 milliseconds, right? So that's 30x speed up. And honestly, the amount of speed up is going to matter with scale with the number of groups. Resampling is a very commonplace where the number of resample groups can be quite large, like thousands. A lot of the times you only have like hundreds to 20 or like tens to hundreds. The speed up's not going to be as good, though there's still going to be something. But the default Xarray thing scales with with number of groups. And so if you have a large number of them, this can make a huge difference. So anyway, you don't have to think about this stuff as long as you install these packages into your environment. Xarray will make the choice for you. All right, now I'm going to switch back to my slides to finish off this doc. Even more stuff I didn't have to talk about. Flox was written for Dask, but now also supports this Q project that some of you may know about. Thanks to John White. It uses the same kind of funky, same kind of nice algorithms and has all the features, or nearly all the features, but it's pretty awesome. There's faster grouped quantiles with just NumPy. I added scans or cumulative aggregations to Flux. This means we can do grouped cumulative sums and then forward filling and backward filling if you've ever needed to do that. This isn't wired up to Xarray yet, but kind of the core pieces have been implemented in a fairly parallel-friendly fashion. And then Patrick and other folks at Coiled have been working on scheduling improvements for these GroupBy workloads, so everything kind of executes smoothly if you have one of these giant GroupBy problems. So anyway, hopefully you think this title is not an exaggeration. We've made a bunch of progress over the last year at just enabling new things and also kind of setting the stage for even better things in the future. The thing to take away is that you should run Mamba install flox and numbagg. This will almost always just improve your life. The other things to take away are you can now group by multiple arrays. This, I think, is fairly powerful and is very, very useful. You can group by a chunked array. This is a little more advanced, but I'm sure someone will find a reason. You can use fast compile aggregations with numbagg. Just install it. It will speed up a bunch of things automatically. You can do things like rechunking to a frequency. This may help, I think, quite a few workloads. Hopefully, you'll be able to write your own groupers soon. We're still trying to figure out the internal API. Soon, you'll be able to shuffle. I think this is going to help potentially with a bunch of these downscaling, detrending, kind of climate type workflows, particularly things that need quantiles. Is where I think this would be a big help and potentially a lot more. But thank you. Thanks for listening.